Hello, everyone. Thank you for joining us at our final workshop of the day, Creating Machine Learning Retraining Pipelines with Mohamed Sabri. My name is Faraz, and I'm one of the co-organizers here at MLOps. Just before we begin, if you have any questions, please feel free to ask them in the chat. Also, a quick reminder that the talks for tomorrow are actually hosted on Hopin. You would have received an email last night with the access to Hopin. Please do check your spam folder. If you have not received that, please send me a message here on Zoom, and I'll be able to send you the link. And I'm very happy to welcome Mohamed again, and I'm going to hand over the virtual mic to him. There you go, Mohamed.
Awesome. Thanks a lot for organizing all this. So yeah, I mean, this is a hands-on workshop. We'll be basically looking at Kubeflow for a specific purpose, which is the retraining of a machine learning model in an automated fashion, so an automated pipeline. Here, yeah.
I'm getting a lot of echo.
Give me a second, I'm gonna get my headphones.
And if any of the attendees have unmuted, if you can just mute yourself, please. Thank you.
Now it should be way better.
Yes, it is. Yeah, much better. Thank you.
Awesome. Yeah, so retraining pipelines. Retraining pipelines are basically a strong focus and core in MLOps or machine learning operation. I mean, deployment is important as well, don't mistake me, but being able to create a machine learning retraining pipeline is critical, as well as a lot of machine learning or life cycle of a machine learning project can include retraining, and sometimes it requires you to create an automated pipeline for that retraining. I'll start maybe with an introduction of myself. Before that, maybe talk about the requirements for this workshop and the dynamic. Feel free to ask whenever you want questions in the chat. I'll be more than happy to answer them. This is a hands-on, so I'll be basically developing in front of or live. In case you have, in case I'll share as well with you the documentation. So in case you wanna do the same thing from your side and build up clusters and then create your own pipelines, you can do it live as I advance in the workshop. Or if you want, you can just focus on and listen on what I'm sharing, and then you'll have access anyway to the documentation and the tutorial, so you can do it later by yourself. Obviously here, if you're not familiar with Python or not that much familiar with Kubeflow, Kubernetes, I'm sorry, and the containerization, can be hard a bit to follow. But anyway, you'll have access to the material. By the time that you dig in those concepts, you can go back to this material and then rework the pipeline the way you want. So my name is Mohamed Sabri. If we never met before, I'm a consultant in machine learning and machine learning operation. My main focus for the last 3 years was around machine learning operation. So today, basically, I have my own shop in consulting. We really focus on MLOps. Before that, I used to be a lead data scientist in a company based out of here in Montreal. And I worked the majority of my career in business services and consulting, either in data science or in machine learning operation. As well, today I teach part-time at the University of Texas at Austin, teaching machine learning and data science to postgraduate students. Worked with different companies in retail like L'Oreal, worked with the gaming industry as well very recently doing MLOps, worked with large vendors like AWS, IBM, and as a partner, obviously, and Microsoft. So I've seen quite a lot of solutions and potential projects in the market. So I have a good idea of what's going on in terms of or I think I have a good idea of what's going on in the market and what are the solutions that exist mainly. I published as well a book called Data Scientist Pocket Guide. My book is available on Amazon. I'll share with you by the end of the workshop a link to my book in case you're looking for a book that will support you basically in understanding concepts in data science and machine learning. Unfortunately, I got another book that is ongoing, not published yet, for MLOps, but this first one is really focused on pure data science for data scientists, less for maybe machine learning engineers, but still an interesting source of knowledge. The way I usually work is either by doing a lot of consulting or development in machine learning or basically MLOps. Our approach in MLOps is quite clear. Really, the first hour, by the way, or the first 45-minute, guys, will be more like on a PowerPoint. Then after that, we'll move on to the hands-on portion of the workshop. I'll discuss as well after this about the use case and some details about the specific details about the use case. So usually the way I act in MLOps, I start as always by analyzing the environment, analyzing the projects in machine learning, because the project in machine learning that the company is facing will impact the type of deployment you'll do, the type of necessary environment, the data ingestion pipeline, and so on. Then after analyzing, we're capable of designing, or I'm capable of designing environments really with the low-level architecture, understanding how the systems communicate between each other, which type of development environment is sustainable. And that's something interesting, because a lot of people, they think MLOps is just for the production side. MLOps technically covers all the life cycle of machine learning, including what is happening in development. So usually in MLOps, you're responsible as well for the development environment, like implementing experimentation tracking tools, implementing the proper development environment. Sometimes it can be just a VM or a server shared among data scientists, and you might be responsible of designing and implementing the environment. After the design, we move on to the implementation. So really being able to implement properly the environments and start deploying the first models with the draft of the best practices at different levels, either retraining or deployment. Then you have a portion that I consider essential, which is basically the coaching, the ability to coach people in organization to make them understand what they should do in machine learning operation, sometimes giving them a crash course in how to work on a container base, being able to play with images and so on, being able to think for production when they're developing machine learning, because a lot of data scientists, they don't take in consideration what is happening in production. They don't make their models fit any production requirement. They just develop with no focus on how it will be used in production. They don't as well optimize their code, which is very important, because not all code can be suitable for production. If you're developing microservices, you know that you might need like a code to be refactored. Some transformation might not be suitable because they have like a high runtime. So all this has to be either teach or shared with the data scientists to make them understand how important it is to take production in consideration during the development. How to define an MLOps efficient architecture? That's an interesting question. How could you design an architecture that is suitable for your environment? Which type of question you should ask yourself? The first one is to understand what is the level of expertise in MLOps do you have or willing to hire? That's usually something I ask the manager. I'm like, are you willing to hire someone, or you just want to have data scientists and you want to see or find a way to actually cut from that side of MLOps? And this can impact the decision of going with specific type of end-to-end solutions or building up maybe a more custom environment. What type of inference, obviously, in ML are you looking for? Are you looking for real-time inference, batch inference, streaming? What is actually more suitable, not just for one use case, but for all the potential use cases that you may have? how many, and that's an interesting question, how many machine learning projects do we have in line in short term, mid-term, and long term? This question is interesting because if you are a, I don't know, a small company that basically deploy or is looking to deploy one or two models / projects in machine learning, the way you design your environment can be something very simple with nothing sophisticated. But when you are a large bank and basically you know that in your pipeline you might have hundreds of projects coming in on a midterm, long term, well then your MLOps architecture wouldn't be the same as the small company, and that's very important as well to take in consideration. And this brings me to another question, which is automation. Because when you start having a lot of use cases and a lot of models to deploy, you need to maintain them. You need people to maintain what is in production. How could you scale something if you have hundreds of models in production? How could you scale your human resource? I'm talking about people here. You need to hire another 50 or 100 person to be able to manage those environments and maintain what is in production? Usually, no, it's not what you want. You want to scale in a more efficient way. And that need requires having automation, the ability to automate with specific open source or commercial solutions, automate your CI/CD, automate your pipelines, automate your redeployment, and so on. That's a question that might sound like not that much relevant, but it's usually important, especially from the perspective that I work on with customers. It's which type of vendor is your company working with? Is your company more open source or enterprise? I got customers that are pure 100% open source. So every time we're sitting and they're like, hey, Mohamed, look, I don't want to get approval for any enterprise solution. We are buying for open source. So all what they want is open source, but open source has its pros and its cons. Usually its cons, it's the versions and the ability to maintain what is in production or have been deployed. Enterprise would be more usually end-to-end with less code or low code or even no code sometimes. And some companies, they're buying for AWS, so you have to work with SageMaker, other on Azure ML, and other on Google Cloud. So that as well usually plays an important factor in the way that you'll design an MLOps architecture, or actually which tools or solutions you would have in your architecture. The last but not the least of the questions is the data science team following the state of the art when it comes to source coding and versioning? This is usually, the answer of this usually is no. Data scientists, they basically focus on their logic, process, their methodology of developing, but usually the code can lack of optimization, can be just on local with no commit. Very few, because usually they work on notebooks, so they don't see the purpose of committing a notebook. And obviously, it doesn't take in consideration production requirement. So you, as a machine learning engineer on an MLOps individual, your role as well is communicate and be a bridge with the data science team to be able to share best practices and state of the art when it comes to like code refactoring, code optimization, production requirement, versioning, and so on. That's a part of the MLOps as well. Being in charge of the life cycle, and it includes the development process. Maybe you're not developing the models, but you have as a responsibility to share and spread best practices for development. This is the typical like microservice design environment that will be pure open source. Here, for example, we have Kubeflow, which we will see today for automated pipeline. You can use GitHub Action, GitHub with the Git Action. You can usually need a model registry, which can be a Google Cloud Storage, or you can even use MLflow for doing your model registry. Then you have model serving. One of the favorite tools that I have is called Seldon. It's basically a startup in UK. They have quite an interesting solution. I think they present usually in MLOps World Conferences. And then, yeah, something very important as well is performance monitoring. Your ability to monitor performance. You need something to be able to monitor the model performance. That's very important. This is another type of environment, which is stream environment. Stream environment is interesting as well. It has a different type of design and dynamic. It's more suitable for IoT type data, large live data source feed, and basically you need to be able to process this data. I would say streaming environments are harder to maintain. They are harder because they are less popular than microservices, obviously, but still it's a great use case, and it has like it can bring a lot of value for specific cases, like when you have like when you are a telecommunication company, manufacturer, all sort of companies that have this type of live feed data, including for example IoT. I mean, you have as well the ability to merge and create more hybrid design between stream and microservices. So you'd have a portion of your models and so on deployed as a microservice, and the data being ingested in streams. That's a possibility as well. Some of the type of technologies and tools that you see in the market, and to be honest with you, if you're trying to be tool focused, you'll have a hard time because there are so many of them. And I mean, if you're looking for a job later, obviously knowing something like SageMaker, Azure ML, this is cool because they represent a good share of the market. But obviously, if I was you, I would focus more on knowing what exists, focusing more on learning the open source, because usually the open source are more complex, because they are usually more, there is more code to do, more code to build compared to commercial solutions. But then you can, for example, I learned Azure ML probably 6 months ago or less than that, and it took me 3 weeks to start being comfortable with it. So at the end, the learning curve is okay. By the time that you know what you're doing and what you're looking for, I mean, an AutoML solution is usually quite the same logic from a vendor to another. Deployment, same thing. It's a bit of the same logic. If you follow the documentation, you're capable of understanding what's going on from that side. But keep in mind that a lot of MLOps is about tooling. That's what it is. It's the reality. It's about specific like tools that some companies might want to buy, or specific tool that you are buying for. So now that I gave like a small introduction about this, I would like you maybe to tell me more about what is MLOps for you and why do you feel it's necessary. Let's ask maybe Chris Cochet. Chris, how are you doing today?
Hey, how are you?
I'm doing good, thanks. And you?
Good.
Awesome.
Yeah, so for me, I think a lot of the focus has been on modeling, and MLOps is around obviously production and maintenance and tracking the performance of the model. So what I'm interested in is knowing a bit more what are the tools, but which one are going to be at least stand out and not too complex to use and not spend my time in YAML files. So I've used GitHub Actions and sort of open source such as MLflow, which are pretty good tools. Also focused more on the open source. So those are the areas I'm sort of interested in. For me, MLOps is just trying to bring value to the business. Ultimately, you're maintaining your model is some sort of app, just like any other apps in some ways. It should be bringing value. It should be performing properly. It should be quick to use if you're having that in front of users. So in a nutshell, not really different than typical sort of applications that we have out there, except it's a model. So that's my view, at least.
Yeah, I mean, obviously, if you want to do less YAML file, you'll probably want to turn to commercial solutions, because Open source is usually, I call it high code. So you have a lot of coding to do, and it's up to you to do the configurations, the configuration files. Kubeflow has something interesting, is that you can use the SDK of Kubeflow to convert a Python pipeline to basically a configuration file that you can upload on the tool, which is cool. So you don't have to do that step of creating by yourself the configuration file. But yeah, I mean, MLOps, if people look to specialize in it, I always say you need that Kubernetes knowledge, and you need container and containerization knowledge. I mean, it's important to have it. It's like someone specializing in DevOps with no knowledge in Kubernetes and Docker. Let's ask someone else. Let's make this session more interactive. Alex Adonki.
Hey, hi, how you doing?
Doing good, and you?
Doing good. I think MLOps for me typically is how I kind of, as you were mentioning about the containerization, how do I get my code that I've written on my, maybe a SageMaker or, my local, a GPU, and then take it to a production quality, and then create that CI/CD pipeline, like how I would typically do for any web application or any kind of a development cycle. And then the next stage would be, once I have this model, in a typical production world, we possibly don't want to kind of launch that immediately for all the audience, but maybe do a canary release or an A/B testing on those models. So the whole MLOps cycle kind of helps me kind of get through to that end to end.
That's interesting. I like your vision of that, and this is a good representation of what you could do potentially on a day-to-day basis. I mean, a lot of people, usually I can give you feedback as well about what I live, and what people that I know live as well in the MLOps field is you get hired to do MLOps, but you end up doing too much DevOps. That's something, that's a reality, but that's usually where there is pain in the workflow, in the DevOps portion, in the CI/CD, in the code refactoring. So in managing environments, for example, Kubernetes cluster, and then deploying. So all these can be potentially painful for the company. So expect from a machine learning engineer, or at least an MLOps engineer, to do maybe a bit more of the DevOps portion of it.
Absolutely.
So just a little reminder, and that's something a lot of you probably know, MLOps is definitely not just about deployment. Deployment is a fraction of what we do. We spend a bit of time. It's like what they say about data science. It's 20% machine learning model, and then 80% preparing for it. Well, here is a bit the same thing, even if the ratio are way more aggressive. We probably spend 10% on the ML code, and the rest is spent on configuration, automation, metadata management, serving infrastructure, monitoring, and so on. I would say really where company they usually like do things on a rush with no deep work behind is the monitoring, not the monitoring of the health, but more the monitoring of the performance of your model. You usually end up being a guy who checks like a Power BI once every 2 months and say, hey, the model is doing just fine. So with very inadequate like metrics. And that's something I have seen, and I feel that monitoring of performance should be more value, because at the end of the day, what's the purpose of deploying a machine learning model if you're not sure 100% of how it is performing in production? I mean, it's like running a sprint or a marathon completely blind. You could make it, you could not. But at the end of the day, for me, it's a portion that should have more value in the process and should take more time to really do a proper analysis of how we will monitor the performance, which tool to use, because there are some good solutions for, it's called NPM or model performance management. And as well, like I said, building up like proper metrics. Which metric? And usually the statistical metric that we use in a data science project, machine learning project, like, I don't know, accuracy or precision or recall, are just not you cannot adapt it in production. You need metrics that will be based on other, on either business side, so understanding or building up metrics that are more related to the business itself. Like, for example, can be conversions, can be a lot of things, because you want to reflect how good is your model in bringing either money to the company or reducing costs, but you need them metrics that will help you show that your model is being effective and that it brings concrete results for the company. So we could consider MLOps like a bit of what's going on in DevOps if some of you have a DevOps background, but it's for obviously machine learning with the continuous integration step and or phase and continuous delivery as well, and what we call continuous training, which will be our focus today. We'll see how we can do a good continuous training. So Kubernetes, if you don't know it yet, please set up this as an objective. Learning Kubernetes, learn how at least to be a user of Kubernetes. I'm not asking you to create a cluster from scratch by yourself of Kubernetes, but at least to be able to, when you create a Kubernetes cluster on the cloud, to be able to deploy your applications and so on it. And this will probably require you, if it's not already the case, to have more knowledge on containers, Docker, for example. Kubeflow is a super interesting tool. I think I discovered it like probably maybe 2 years ago. I'm not sure. I don't remember exactly, but it was a good finding. It was a good finding because basically I realized that it's a good competitor of Airflow. Airflow is another tool for creating automated pipeline and for automation. It's interesting because Airflow is more focused on data side. So basically a tool for doing ETL. Airflow can be very good at it, while Kubeflow have been created with a focus on machine learning. It has a pretty good interface. The SDK is awesome. I like the SDK of Kubeflow. The only thing is, I would say that, yeah, the thing that is interesting about Kubeflow is that a lot of commercial solutions, they basically took Kubeflow and they incorporated in their solution. So you'll have some of the end-to-end machine learning platform that rely on Kubeflow for their pipeline side of the tool. So our use case is pretty good. It relies on a project on Kaggle with Reddit data. So basically here the context is very simple. On Reddit, people, they basically post a bunch of stuff and people, they comment, except that sometimes the comments can be inappropriate. Sometimes someone posting something about like that is sexually related, offensive, whatever, but it's an inappropriate content. And usually in the old world, you would need like a moderator, someone that will basically flag and erase inappropriate comment. But the thing is, it's a long process because you can have sometimes a lot of comments, and it's hard to have moderators every time for every subreddit. So here the idea is very simple. Build up a machine learning model that can basically detect any inappropriate content and flag it. Obviously, we don't take off human from the process, but the human would basically receive the flagged content and then basically say if it's definitely something to be erased or not. Except that here, knowing that we automated a portion of the process, it becomes way faster. So you need less moderator and it makes user experience better. Now, our idea is, okay, we created our first models. Now we deployed them. Now we would like to create a pipeline that can do the retraining of our machine learning model automatically based on new data that comes in, and then redeploy again automatically our model, retrained model to the deployment engine. So here is the process. We have a live feed, we retrain the model, and then we push it back to production, or we push it back to the deployment engine. So, and this is what's interesting about this use case. We'll see how to move from a notebook to production. And it's a long process. Don't mistake me, even if it's a 2-hour session, technically it's a very long process. It takes weeks and weeks and probably multiple people to do that. Being able to have the ML engine that will do the inference, have the architecture first, and then have the retraining pipeline. But with the proper tool, at least you can fasten the process. So our architecture is quite straightforward. We run obviously everything on Kubernetes. So let's say we have a live feed of new data coming in from Reddit. Technically here, it would be like, to make the workshop easier, it's basically a CSV file that I get from somewhere, but it can be anything, any connection to the data that you can do. Then we have a module that will do the data extraction and upload our data. Then we have the module that will do the data pre-processing, because in a retraining pipeline, you need to define the data extraction step. Then you need to define the data pre-processing step, because you need to know what are the transformation potentially that you want to do on your data. Then we build our classifier, so our machine learning model. After that, we can trigger the deployment inside our pipeline. And obviously, all this is automated and can be run under schedule, but as well in other cases can be run under the production model. So if the performance of the production model drifts and goes under a certain threshold, it can re-trigger a pipeline. Obviously, our model will be stored in this case in a model registry. Could be a persistent volume on Kubernetes, or can be an S3 bucket, because here we're working on AWS, by the way, but I'm cloud agnostic. So this workshop can be run on any cloud provider you want, even locally. Obviously, our machine learning inference or machine learning engine will basically, when the trigger deployment is active, it will take the model from the model registry and then basically send back the new image to the inference model. Everything is based on images, even the pipelines, even the components of the pipelines. So here you will have a rollout. So basically there is no downtime. That's what's cool. So your model, when you have a new model that will be trained with this like good results on testing data, it will basically send back as an image to the inference engine or microservice, which will do a rollout and then get the new model. With this, you don't have any downtime. So if you have an integration with an app, you don't change the endpoint and you don't have any downtime. Obviously here, if you see data processing as well in production, it's because, for a simple reason, when you are running a machine learning model in production, not in production, every transformation that you do on the data during the training phase that have led to your machine learning model have to be replicated usually in production. That's why here we have a data pre-processing, because keep in mind that our model, our input data here in production during inference is raw data. So it needs pre-processing first, and then it will be sent to model inference. So before we move on, any questions so far? Yes, you'll have access to everything, the slides plus the the workshop tutorials, I'll make sure that they share everything with you. Awesome. So first thing I'll do is share with you this. So please go on, if you want to have access to the complete tutorial that I will be running right now, please go on the link I just sent on the chat and tell me if it's working for you. It's supposed to be. You'll have access to the hands-on workshop. I hope it messed up. It should be good. Yeah. Awesome. So first thing you'll have to do is set up a cloud account if it's not already the case for you. I'll leave this here. First thing is set up your cloud account. Here we work on AWS, but later if you want to run the same thing on another cloud account, Azure or Google or so, you could, no problem to that. The first step that usually takes a bit of time is, and I didn't do it before, is basically us creating a cluster. So MLOps Word, we'll click on service role. Here, obviously, the first thing you'll have to do is create an IAM role. Here you'll have basically to create a new role. This basically will allow authorization to resources and so on. Very, very important to set up for whatever you're doing. And usually the majority of problems that you're facing in setting up instances or so are related to that. You click on AKS here, then you click on AKS cluster, and then next you'll have the basically permission tags. Then you click next tags, next preview, then you give it a name, and it should be by doing a refresh, it should be available here. Here we'll take this one, then click next, then next again, next, and then create. Okay, it's gonna take a couple of minutes to basically create. Meanwhile, I can take questions if there are any questions so far. By the way, this use case is an adaptation of an existing use case that I refreshed, have been published by Seldon. Something I didn't share is here our ML engine is Seldon. I'll send you maybe links to the official website of Seldon in case you want to have a look at it. It's an open source tool. Interesting. I have one customer that runs on Seldon, and sometimes, to be honest with you, can be headaches, especially with the version of the tool, because sometimes the procedure for deployment can change from one tool to another. As well, it's using Helm, so sometimes it can be problematic with versioning from Helm 2 to Helm 3, and then you change the procedure and so on. But it's still a good tool because it has A/B testing in it, has sophisticated deployment that you can do. And we'll see here it does quite a good job. The second tool that we're using is called Kubeflow. And Kubeflow basically helps you create pipelines. So basically, Kubeflow compared to other tools is that Kubeflow is focused on machine learning. Okay. From the beginning, Kubeflow is more a toolbox. That's something you didn't explain. When I was saying Kubeflow, I was more talking about the core tool, which is a Kubeflow pipeline. But Kubeflow at large is basically a toolkit. I'll show it to you later. It creates a bunch of instances or bunch of deployments for all sorts of tools that are supported. You can have access to TensorFlow, Jupyter Notebook, Spark, and so on. So it's a toolkit. You decide what you want to put in it. And then under the same namespace, it will create all these resources. that can be managed from the same environment. Pretty cool. Like I said, learning curve for the SDK is very smooth, so you shouldn't have a problem master it very quickly, compared obviously to other tools, but they are still a learning process here. Did someone maybe already have ever used Kubeflow in the group and want to share with us his own experience on the tool? Waiting for this cluster to start. Maybe Eric Amel. I'm sure you have good experience with Kubeflow. Kubeflow is a Google tool. It has been created by Google, but I think I'm sure 100% it's open source. So it relies on probably Google contributors so far, but it's an open source tool.
Yes, can you repeat your question, please? I was setting up my microphone.
No, that's fine. I was saying, I'm quite sure you have good experience with Kubeflow. Maybe you want to share it with the audience.
Oh, actually, I haven't used much Kubeflow for production deployment. It was more for POCs. From what I remember with my experience, there was some setups, but once the whole operator and is running, it's like a pretty exhaustive and extensive set of different tools, and can serve like different teams at the same time. So it's like it allows people to, I mean, when I say people, it allows teams to have their own set of libraries and whatever framework they need to work on.
Awesome, that's good.
But yeah, you feel the Google signature. Actually, I have a friend. He works at he works for GCP, and they implement a lot. They implement a lot of Kubeflow on their client sites. So yeah, he told me sometimes they go from some weird handcrafted witchcraft architecture to something cleaner, and it can be seen and felt throughout the user's team, the data scientist, as well as the infrastructure, that it relieves a lot of pressure from their shoulders.
Interesting. I mean, TensorFlow is a Google signature as well, and it's not a so bad tool at the end of the day. So far, Google have published great solutions on the market from the open source perspective. I'm not talking about the commercial solution. Did someone maybe ever worked with Seldon solutions and want to share with us his insight? Or maybe any insight you could have about an MLOps tool that you've already tackled? I mean, I know I'm presenting Seldon and Kubeflow, but again, I'm agnostic, so it could be any other tool in the market. And at the end, the tool is the tool. What matters is the expertise behind it. I've heard MLflow earlier. That's another good tool. What's your thoughts about it, for example? Waiting for our cluster to start.
Hey, maybe I can hop on. I used MLflow a bit, and what I enjoyed about it was it integrates pretty well with Databricks and Spark. So, and as well as any Python environments. So that's the environment. With Databricks, it's really well integrated. There's like a UI, etc. So I've liked it a lot.
Well, they've created MLflow, but you know what's funny? I was doing a comparison of tools for a customer for experimentation tracking, and MLflow was one of them. He won the race, by the way, but it has been created by Databricks, and it's still being like the major contributor is Databricks for MLflow. And what's funny is I was looking for the roadmap because there is no user management for MLflow, which was annoying for my customer. But the funny thing is, I was reading on some forums that Databricks they will never release like a user management for MLflow, just because when you have that problem that you have the open source stuff that you position on the market, and at the same time you have your commercial stuff, you're like, hey, I shouldn't give them that much. So they're giving us good features, but they don't give everything just because they want you at the end to move to Databricks. So, but still, I mean, MLflow is an amazing tool. I did a comparison compared to Comet ML and to weights and biases. What else? SageMaker as well, their portion for tool comparison. And yeah, I mean, MLflow is, I would say, is dope. It's a good tool.
I didn't realize Databricks had created MLflow.
What do you mean, Ashok, by MLOps doesn't orchestrate and manage your resources?
Yeah, like for example, if you have a pipeline and if you want to spin up a EC2 instance with GPU, it cannot do all those things. It is just a pip install away. MLOps, all it has is a repository and a UI to view the metadata. It cannot manage your hardware like how Kubeflow can do for you. Because it's sitting on top of Kubernetes. Kubernetes orchestrates all those things. If you want to scale out a particular component in a pipeline, you can do all those things with Kubeflow, but you cannot do any of those things with MLflow.
MLflow. Well, MLflow has two main modules. MLflow has the experimentation tracking, which is nothing to do with orchestration. It's basically ability to capture metadata from experimentation data scientists they do. And MLflow has as well a model registry, which is pretty cool. So you can register your models in it. Again, here there is no resource to manage. The other portion is model serving. They have quite a basic module for model serving, which is interesting. But MLflow is definitely not for orchestration and management of resources. Sure. So you would be more using Kubeflow in that to do that.
True. Yeah, if you see actual in an ML pipeline, you have some components that need CPU, some components that needs GPU, some component you need to scale out, some component you don't need to, right?
Yep.
So if you see all those workflow, MLflow doesn't do anything. Right, it is just a pip install. It's got a basic repository, basic UI. If you have just a lightweight data science pipeline, maybe that's okay.
I mean, you can integrate Kubeflow with MLflow. You could, for example, have your pipelines, and basically they send metadata to MLflow. So MLflow would be just for tracking the experimentation. No necessary for no need for resource management in that case, and so on. So. Yeah, I mean, for me, there is no tool in the open source field that can do everything and be good at everything. Usually, the best tools are the ones that have focus on something very specific.
True.
Yeah, Parshad, what's your point when you're saying you have your reservations for model data history and model serving?
Yeah, so what I was saying is that I don't specifically find MLflow to do where and how the model was made with, meaning the data set history, meaning what data set I have used. So which in terms mean that the feature store and the versioning of data and all of that, I don't think MLflow has. I mean, if it had that, then probably it would be great tracking tool for how the models and were generated and with which data set. But yeah, I mean, apart from just using as a pure model registry itself, I think it is a great lightweight tool. But in order for me to track how did I come about to build this particular model using what data set, I think it kind of lacks that, and I do not specifically like that, like, because the data changes so much, and MLflow is just not able to keep up with it. So that's where I have to like manually put that external thing. I have my own feature store which I use, which I've made because of a small team. But then I also version the data, and then I add that as like, this thing set parameter or a set something, and do as a data set a data set version is equal to v1.0. So I add that explicitly instead of it knowing by itself. So that's what it is.
Yeah, it doesn't have the option for lineage, so it's hard to track. You can still use the model registry to version your models, but for data history, you will have to explicitly, when you upload the table or the CSV to MLflow, say, hey, this is like version 1.1, but you cannot track it over time. So you'll have to look at every experiment and every run, and then look for the data used. But you're completely right. Other tools like weights and biases, which are commercials, they have that lineage aspect. You can do lineage and go understand how the model was created and based on which data.
Yep. That's what. That's why I like WNB a little more, but I do not use it because it is paid, so I can't complain a lot there.
That's what I was talking about, the culture. Depending on the culture you work with. Go ahead, Alex.
No, a quick thought. I mean, what I think that there's still a workaround wherein you could actually dump your data set, whatever that you're training, into your artifacts in the MLflow, and then keep it as store. That's kind of one way of keeping track of what data set you're using. And obviously, since you're using the feast, you have the feature store, and then you have the versioning there. You kind of can link the data set you're using to the one that you already have stored in the artifact. Just a thought.
No, that's definitely a good share of your experience. Obviously, Ashok, MLflow doesn't have hyperparameter tuning, not from what I know. But yeah, I mean, it's an experimentation tracking tool, and like I said, it's open source. Or at least we have the open source version accessible on the market. Databricks, the version of MLflow on Databricks, that's a good question what it supports, but Databricks complement it with other proprietary solutions they have. Yeah, Adrian, that's definitely true. We can use Kubeflow pipeline to load pre-trained model and use AWS SageMaker for deploy. You could use actually SageMaker to trigger instances on SageMaker. So basically, you could ask Kubeflow. So with that, you lightweight your pipelines and ask every specific component on Kubeflow to start a SageMaker instance for training, and then it will train on SageMaker, and then after that you can send the model to a SageMaker registry, and then basically be able to do the triggering for the deployment. SageMaker is very interesting as well because it has that programmatic aspect. So you can programmatically communicate with SageMaker and send it either data, training, trigger instances, and so on. After this, someone had something?
Oh, no, thank you. Thank you for
the
answer. Yeah. Thanks.
Well, that's a champion-like fight between Airflow and Kubeflow. Both of them are good. Airflow is based on DAGs. Its SDK has like more tough learning curve, but Airflow is very good as well. But yes, the main purpose of it was for strong, like deep data engineering work, loading data, going for ETLs, and so on. That was the main purpose of Airflow. Kubeflow was really, or Kubeflow pipeline was really focused on and machine learning first. All right, so we'll create node groups, because this is something very specific to AWS, is that when you create a cluster, Kubernetes cluster, it comes like an empty shell. So you need to create the nodes that will compose your cluster. Here it needs like a node IAM role. You have to create one here following the instruction I was giving. So basically click create role, then assign or add up 3 policies, which will allow like AKS worker node policy, EC2 container registry, and another policy. I have seen Kubeflow tutorials using Apache Beam versus Airflow. Any idea on why Beam DAG Runner is compared to Airflow? That's a good question, and I don't feel that I have enough experience for Apache Beam to give you like a feedback about it. But if someone else in the crowd can potentially provide an experience or thoughts about this integration, that can be cool. So let's take EC2 role and then click next. Here we keep everything as default. Here it has to be a T3 medium. We'll set up the minimum size to 6, the maximum to 8. And this is cool about like the ability to scale node. I found it very interesting. Then we'll click next, create. And now we'll wait for it to basically create. Takes again a couple of minutes. I'm sorry I didn't have the time today to basically set up in advance these 2 major components, but I was having a video shooting in my place and so on with cameras and stuff. It was fun. Like I was talking all day. Now I'm talking all night. I'm East time, by the way. So yeah, let's wait a couple of minutes. What can we do? Meanwhile, what I can do is create Cloud9 instance, because we'll need it to basically run as an IDE. Why I use Cloud9 is, okay, if I had to make you guys do the workshop on your laptop, knowing that everyone has a special configuration on his laptop, including that some of you have Mac, some of you may be running on Ubuntu, and me running on Windows, that's going to be a nightmare. So I rather use like Cloud9, so at least it's universal, the same for all of us, with the same command. So I'll create environment, then we'll call it MLOps 101. Next step, it has to be a T3 medium. So we click on other instances and we take T3 medium. Next, create environment. Awesome. Let's get back to AWS meanwhile, and here we will do a small setup for basically the volumes, because I don't know why, but Cloud9 comes with a 10 gig, and I need something like close to 30 to be able to run comfortably like the workshop. So I'll basically go here, click on, where is volumes? Oh, it's probably in storage. Then click on my volume, and then simple thing I'll do modify. Let's enter 35. That's what I said, yeah, 35. Then modify. Are you sure? Yes, I want. Close. Now let's do a small refresh. Yep, I got 35. It's supposed to be good. Sorry. Then we enter this long command, which will basically help us with the attached volume. So it will be available for us. Yep. Now let's enter the FH. Yes, I got I got my gigabytes available here. So before we move on, or actually we can process that. We can install. Let's install the following. So we'll install kubectl, obviously. You can copy paste like by batch the commands. It will basically install all what is required either for communicating with the cluster or being able to interact with our cluster and so on. It's good. Now I go with the AWS IAM Authenticator. Yes, it's good. I'm not sure in my workshop if AKS CTL is, I think it's used. Yeah, it's used by an internal bash file. So let's leave it. Now we'll have KF CTL as well installed. Awesome. So now we're ready. All what I need to make sure is that my nodes are up and ready. So I'll go on AKS. I'll go on my cluster, go on MLOps. Oops. Oh, it seems to be ready. Okay, compute. Yep, it's ready. That's perfect. Awesome. Now we need to connect to our AKS in AWS. For that, what you will have to do in terms of procedure is creating an access key. So basically, you need to go in under my security credentials. Then you go under access key, and you generate a new access key, which will be downloaded. After that, basically, you'll have to open the CSV file. So let's go under root, look for root key. Yep, root key. This one is the one. There you go. So I got my, basically, technically, you don't have this. You have just this, your access key with secret. I'm not supposed to show you mine. But worst case, I can change them later. Then after that, we will basically, we need to change the environment variables and enter the proper cluster name in my IAM authenticator command. For that, I'll go on my CSV file, and then I copy those three. Awesome. It seems to be working. And the last is basically, but not the least, my ability to connect to, let me see, how did I name my AKS cluster? Yeah, MLOps work. That should be good. So let me connect. Okay, that sounds good. Now we can move on to the next section, which will be us installing basically Kubeflow on our Kubernetes cluster. Any questions so far? Okay, so let's export some environment variables for Kubeflow install. The only thing you'll have to do here is the second line, make sure that your environment variable AWS cluster is cluster name is your cluster name. Awesome. Now I'll source my let's create a Kubeflow directory. and then I'll get the configuration file. Let's download the configuration file, and now I can show you the configuration file. So depending on the version you want and you work with in Kubeflow, because here I got the version 1.0.0, but you can get like more recent version or older version. 1.0.0 is a stable one with existing documentation around it. So I usually use this one. Probably very soon I'll have to update to another version. And here what you see basically in your YAML file, and I'm sorry, Chris, but we'll be working with YAML files in this workshop.
All good. You can't get around YAML files.
Yeah. So here basically I set up the customized config that will get me the proper tools to use. Here, if you go have a look, you'll see some tools that Kubeflow relies on and other tools that are available like Jupyter Web App, Spark Operator. We have PyTorch here available, TensorFlow and TensorBoard. You have Katib, which I'll show later, the pipeline tool, and other tools, and as well Celdon and other tools that you can add up. You have the NVIDIA device plugin, which I suppose will help you support GPU. I think there were a question around GPU, and yes, you can do a bunch of interesting things with Kubeflow when it comes to GPU support. All right. Yes, my cluster name. Where is it? Okay. Change the region. I'm in which region? West 1. So West 1 it will be. Yeah, sorry, the change that I've done. Let's slide this one. Yep. Then I'll make sure like the session read configuration information from the config file by adding up like this environment variable. And then I'll go again on, sorry, the in, I think. Yeah, sounds good. I'll go on, I use Kubeflow, or actually kfctl apply with my configuration file, which is supposed to basically start the setup of my Kubeflow. It takes generally no more than 2 minutes. What is going on in this step? It will basically deploy every component that has been basically declared in our yeah, exactly, in our configuration file. And that's what you're looking at. Basically, it's right now it's not, this is not running on my local machine, my Cloud9. It's from Kubernetes side, because it's basically deploying, like you can see here, you have, it's creating config maps. It's basically deploying here the application, or deploying ALB ingress controller and every component that we have seen earlier. It comes as well with cluster role being created and role bidding. So all these are basically, you can consider them as either modification or rules we add up to our Kubernetes cluster. But what, as an outcome, we can have a look at get pods and Kubeflow. And yeah, we can see what has been basically deployed and up and running. Here, for example, we could look at, got it, thanks. We could look at, for example, notebook controller. I think we have Celdon as well here, Spark operator, obviously, and that's something very important. Here, I left almost everything in. So basically, the majority of the components are just deployed. I'm sorry, but technically, you can get rid of some of them. Make sure that they are not essential for Kubeflow to run, but for the rest, they are optional. So you can take them off, and make a smaller cluster of Kubeflow with the toolkit. It's a toolkit at the end, so you decide what you want to put in it. Now we will basically expose Kubeflow dashboard. If you're not familiar with what exposing means, keep in mind that you have three main components, if we can simplify it, on Kubernetes. You have what we call deployment, which I call is the insurance. Here, no, we didn't define the number of pods on the cluster. You can see it on the configuration file. We didn't define that. But like I said, the deployment is your insurance, like on the house. The pod is the actual house, and the service is the door. Obviously, you need a door, right, to enter in and go out, and that's the service. So we need, when I say exposing, I just need basically to change from like to change or put a door into my house to be able to enter. And why the deployment is like the insurance of the house? Because the deployment is what, if your pod fails for any reason, okay, the deployment is, or crashes, the deployment is supposed to take care of starting a new pod. It will start the same as the initial configuration was based on the image that you were using. So this is a very simple explanation of what is going on. Obviously, here you can have a look at your kubectl get svc. Let's see what is here. Yeah, this is like service, but I'm not in the right namespace. So if I go under issue system, yeah, a bunch of services that are being used by Kubeflow. And the others, now I wanted to expose load balancer. That's it. You have the ability to expose as load balancer, node port, or like I think cluster IP. But to be able to communicate with the outside, you probably need a load balancer or a node port. Now let's get the IP. Yeah, I got it. Now it shouldn't be working, and it takes a couple of seconds generally before starting. There you go. Now I have access to Kubeflow dashboard. Let's name it MLOps Word Finish. Awesome. So now I'm in Kubeflow pipeline interface. I'm quite sure that you can set up a basic user management system here for your Kubeflow. Again, for these type of things, that's why open source sometimes can be dark, is when it comes to security, okay, user management, it's always like so-so. It has to be, you have to figure out how to secure it. by adding up an ingress, by finding ways to basically control IP, control traffic. It's really up to you in the open source sphere to manage the security. And if it fails, you cannot blame anyone because it's an open source tool. So it will be up to you to manage the issues and problems. So now let's go on pipelines. In pipelines, no, not pipelines. I'll show you just the interface of pipelines. We'll go through experiments. You have as well an artifact module. So you can use actually Kubeflow as a artifact registry at large with the ability to register your models in it. Then we will have like notebook server. So basically another cool thing is if you use Kubeflow, you could potentially have at the same time your data scientists working on notebooks in the interface, and there you go. Your data scientists working on a notebook server. They can start like ephemeral instances to run their models and train their models. And from another side of the interface, you could run your pipelines, which is cool. And in the same namespace inside your Kubernetes cluster, you could have your deployment module. That's why Kubeflow is good as a toolkit, but as well good for pipelining. So let's create a new server, name it whatever we want, simple test 1, 2, 3. You can use to start your basically Jupyter. You can use existing images. Here we'll go with the 2.1.0 notebook CPU, but you can use a custom image. If you have your own image, you could use it. Set up like some additional information regarding CPU and memory. Increase them based on the availability you already have on your cluster. That's a workspace volume. You can add up data volume if you want to add up like data sets, for example, that are mounted as a volume on your Kubernetes cluster. Additional configuration. Then you can add up GPU. We were talking about GPU earlier. You can have that cool feature of adding up GPU. And now we click launch. Any questions so far? Something, guys, you want to discuss about? By the way, I like this group for today because usually sometimes I present this workshop and there is no much questions, no much talking, but today I'm very happy because you have a lot of interaction, and that's quite cool because that's the main purpose of this kind of workshops. So let's connect to my Jupyter. Now I'll start a terminal. And then I'll basically copy my GitHub or clone my my repo. Awesome. Let's close the terminal, and it's supposed to be here. If you go under ML training Reddit, this is basically what type of things that data scientists deliver. So for this project, for example, they used, I think, logistic regression crossed with some deep learning models, basically getting like Reddit data set. The type of data we have here is obviously like the body of the comment, then a score, then the creation date, then if the comment was removed or not. They've applied like some transformation like TF-IDF on the data. Clean transformers. They tokenize it as well. So they use the tokenizer to be able to tokenize the data set. They tried the logistic regression here, providing specific results. Then you have the confusion metrics, a RAG curve, precision recall. Then they tried a deep neural network model with one embedding layer, one flattened layer, then two dense layer, or actually one dense layer and one output layer. The model has been serialized here in JSON and in HDF5. Interesting, because, okay, for deployment, let's take maybe a couple of minutes to discuss about this. Here, when deploying a model, sometimes you have that opportunity of just a data scientist sharing a model in a pickle, JSON, or H5 format. And then what? I mean, your ability to integrate or to deploy that model, we're not talking even about retraining, we're talking about the deployment. Your ability to deploy becomes a bit of a headache because you need the transformation associated, because you need a pre-processing. You need to understand the format of the data input. You need to build up like integration with potential data source if there are additional data sources that need to be ingested by the model. And you need to understand what is the version of the model supported. Usually, and that's why they exist a specific type of, I call them the beasts, and the beasts are the machine learning engineers. Because machine learning engineers, they do two. They do both. They create notebook like this, but then they're capable of deploying. And that's what's interesting is, what is interesting is that when it's the same person that created the notebook that is deploying the model, it's more smooth, more efficient, and faster, because he knows what he needs to deploy, what's the pre-processing, what's the version of the model, create a requirement file, and so on. So it goes very quickly. Machine learning engineers are the future in the field of AI. We cannot, I mean, your question is interesting. We cannot deploy a notebook code to serving. We can, but what I'm saying is when it's a different person that created the model and the notebook versus the person who deployed, it's a longer process because he needs to understand what has been done. He needs to understand the pre-processing. And sometimes it's not even people that have background in machine learning. So he have no idea of what the model is doing, what's the purpose of the pre-processing. So, and it gets very complicated. And that's one of the reasons why there are so many failures in the field. So many project fails, mainly because of MLOps. And I do believe that a part of it is due to that. The fact that there is a great gap when you want to deploy. And machine learning engineers are that bridge that will fill this gap, because you do at the same time model development and you're capable of deploying your model. Obviously, machine learning engineers are not MLOps engineers. So they probably don't have it, like they're not experts in Kubernetes. They're probably not experts in building up configuration file, but they have good and enough knowledge to be able to manage the deployment and be able to do the deployment and convert their own code or their team code to deployment through refactoring and so on, and code optimization, obviously. But yes, you can deploy not a notebook as is, but at least like I said, be able to save your model, then take the pre-processing that have been done, wrap it up, and then create, for example, a microservice. Awesome. So now that we're good with that, obviously the other notebook is just like an EDA, so additional EDA that can be performed. If you want to read up more, I can send you the link to the Kaggle competition for this specific project. Now we can go back and head to our Cloud9. Now we'll get our basically our dummy case, one of the dummy case that I wanted to show you here. Kubeflow session 4. So this is typically a basic like implementation. Yeah. Obviously, there are documentation regarding that. That's why my role in life is to convert as much data scientists to become machine learning engineer. That's my purpose for living. It's basically converting data scientists to become machine learning engineers because we need more machine learning engineers. I hope that's a good purpose in life. Yeah. So yeah, I mean, KFP, the SDK, very smooth, nice. Here you can see a couple of examples using the decorators, defining functions. A very, very simple example. I didn't create that example. It's available on Kubeflow GitHub. So have a look at it. Very simple, printing out a couple of stuffs. This is a basic. We'll get back to our. Don't worry, we'll get back to the main beast, the pipeline, the complex pipeline that we want to deploy. This is just an example, a warm up for us to start with. Obviously, here we do a special maneuver. Is that we compile our Python script as a configuration YAML file. You have the other option of connecting to your Kubeflow, a bit more complex, but this one is easier, and for demo purposes is easier to set up. All what you have to do is run your script, then it creates like here like a YAML file that you can basically download, and then go on Kubeflow, then go under pipelines. Then click upload pipelines, enter the name, test 101, test 101. Then upload it from the file, choose a file. Then you click create. All right, we have our graph, pretty interesting, pretty cute. Now we need to create a run because we want to execute our pipeline. You choose the experiment. Here we'll choose default. Obviously, here is where you have a bit of a magic. You have the ability to set up recurring or to set up one-off. We could set up recurring with periodic or cron. Yes, the graph has been created from the YAML file. The YAML file giving all the instruction about what is inside every component, which order the components appears, and so on. Could set up here our pipeline to run every minute, every hour, every day, every week, every month with starting and ending date. Pretty cool. The dependencies, that's a good question. The dependencies, that's a good question. The dependencies are defined. Dependencies. I think I got it in the other example. I created a requirement file, and this requirement file is converted with the image. So basically, I build an image containing it. Yeah, so this one actually doesn't require knowing. If you look at the yeah, and it comes inside the requirement file. So you have to create a requirement file, obviously, but we didn't here because this is basically a dummy example. It doesn't take any dependency here. So let's run the type of, but I'll show it later. I'll show you later. We create dependencies because we have stock coming from everywhere and we need dependencies to basically run our code. So here, let's go with the one-off, and then we can click start. It will basically run our pipeline. I'm very transparent. I can tell you something. The main problem with Kubeflow is this. Now the interface is buggy. Okay, And now it's been good. Today it's been okay. There was not that much of a problem, but sometimes the interface can bug. From the reading that I did on the web, the bug comes from the ingress itself, and they basically advise to change the ingress, which will usually, based on the reading, reduce the bugs. So if you are experiencing bugs on the interface of Kubeflow, it's probably due to the ingress. So here our pipeline, let's give it a second and then I can show you. Yeah, so here, pretty cool. You got like, when you click here, you can have access to the artifacts, okay? Input, output, very important for you, so you can understand basically the flow, the volumes that have been mounted, the manifest, and then you have access to the logs, which is pretty cool. You can even print out inside the artifact like your any visualization. Let's say, for example, you created a confusion matrix inside your pipeline. You could print it out here because Kubeflow supports that that feature. Yeah, so this is a very basic pipeline that I have run. What do you mean by okay by pipeline?
Oh, I mean, I'm sorry. So I think in the artifacts, whatever we are generating is per pipeline. Like this is one pipeline that we have generated, right?
Yeah. Here, the artifacts are basically, here we have actually 3 pipelines that were combined in one pipeline. You can do that, basically combine multiple pipeline into one. So here, in theory, everyone is considered as one. They are, and they run basically under the same run.
Right. So if there's an artifact from the pipeline 1, 2, so how do we differentiate those artifacts?
I'm sorry, I didn't understand.
So you just saw the in the graph, in the pipeline output, when we saw the artifacts, in the artifacts, if there are like 2 graphs, one by the pipeline 1 and one by the pipeline 2, so how do we differentiate?
Oh, it's basically independent from the pipeline 1 and 2. So basically here you'll be able to see the artifacts associated with your flow, not to all of them. So it's not common to all of them. Every time that I click on this, it will show me the logs for this specific. And by the way, to give you an understanding of what Kubeflow does, for every component that I show here, it creates a specific pod. So a specific pod is created, ephemeral pod, and it will be marked as completed. So it doesn't run forever, actually. It will run just for the purpose of this specific pipeline that you.
And we can know that from the kubectl on command line.
Exactly. Right? So if we type here kubectl get pods and Kubeflow, it should basically show us, yeah, here. 5 passing pipeline completed. So yes, you can. I always use kubectl because it's always good to see what is happening under the hood. Even you can dig in, and technically here, when you click on logs, and I show you later, you can have access to the logs of your pod. So that's quite cool. With that, you can basically understand what is happening and why it fails. So it's easier for debugging. Instead of going to your cluster Kubernetes, you can look and look for debugging from the logs of a component. Thank you. Awesome. So now we did a bit of a warm up. Now we'll download the real, or we clone the real data set. We're already in environment, no need for that. And we will basically go under Reddit pipeline. It's under Kubeflow pipeline deploy. And here I could spend a couple of minutes giving you a little bit more information about what is happening here. So basically we have our main Python script, which is actually the pipeline. So here the pipeline is interesting because here we entered some parameters. Those are parameters that basically I will, and this is cool about Kubeflow. What you see here, I can set it up and change it from the interface. And I'll show you how later, but keep in mind that this is opening a lot of opportunities for you, because every time, let's say that every time you want to run on a specific, your pipeline on a specific, yeah, exactly. You want to run on specific data set, or you want to maybe manage, ask him to select only 3 models or anything you want, you can set it up from here and be able to impact what is happening on your components from the UI or from programmatically from the code here. We use some volumes here. I work on an image base, and this is pretty cool because when you work on image base here, every component is an image. So every piece of the pipeline would be an image that later runs like a Python command. I'm not doing anything fancy. Yeah, we use Docker, but we use something else. And I don't want to confuse you, but we use something called S2I. I think it's source to image. We use S2I because Seldon relies on S2I images. So basically, it's another alternative for a Docker image, but at the end, we end up with the same type of images. It's just the procedure is slightly different. Yeah, but those are, this one is basically a Docker image. As you can see here, the parameters are used. So CVURL is supposed to be here. Yep. So it will be used as an input by my different components of my pipeline. Same thing here. We have the clean text transformer, which will clean the raw text that we have. Then we will tokenize the text. After that, we will have another component that will vectorize it. Then a component that will basically create the machine learning model. Then we'll do something special. We need to upload or to load the configuration file of Seldon. Okay, and I feel it is here. Yes, the configuration file of Seldon is basically a YAML file. And it's pretty cool because here you can do interesting things. We can have an orchestration service, okay? And this is dope, like pure dope. Like if you want to brag in front of people, tell them that you orchestrate microservices. They're going to be, who is this guy? He's coming from another planet. And that's serious because not everybody can do that, especially when you have a tool like Seldon. It does the job for you. So here, basically, I created a graph where basically I have orchestration across multiple, because keep in mind that, okay, to have a prediction, I need first my microservice that will tokenize, okay, then another one that will vectorize, and then I'll have the classifier that will basically provide an outcome or a result for my predictive model. And I like this architecture because here we clearly separated the different components, smaller piece possible as a microservice, being all of them orchestrated between each other. I know quite a couple of cases, I don't want to say names, but I'll say I know a couple of cases where they just took and made a large microservice, one microservice that does everything. This is harder to maintain between you and I. I'd rather have like slice everything to the smaller piece possible and orchestrate all those microservices, easier to update, much cleaner. Yeah, I mean, for me, it's a good state of the art to work this way. But we have inside of this, Seldon is doing an orchestration of multiple microservices for us. Yeah, and again, I reuse the same, pretty much the same images from my pipeline for Seldon. If you're lost, I'll get a fresh reminder. The pipeline the first Python file that I show you, this one is basically in charge of this, okay? And the configuration file is basically in charge of this. This is cell done portion, okay? Here, why we do that? Because keep in mind that we need to create our microservices from the beginning. Here we go with the assumption that there is no microservices deployed. And then what happened is when there is a new retraining, it will basically, your existing deployment, it will send new model to your deployment. I don't know if this makes sense to you, but basically here at the first shot, we'll create deployment based on the training pipeline. Then if the pipeline runs again, it will basically retrain the model and then send back the new model to production. Alternative to Celdon, you have Cortex as well, which is open source, but Cortex is cool in another way. Cortex is cool because it's very low code. So it manages everything for you. It's open source as well. It manages everything for you. So it can manage even your cluster. So you can create your cluster from Cortex command, which is very cool as well, but good for some purposes. Here, Celdon is good for people that want to create more sophisticated, complex deployment because it supports A/B testing. It has like that ability to create complex graph, which will allow to do orchestration of your services. But yeah, I mean, there are a couple of good alternatives. MLflow is an alternative as well. It does model serving. So where I was, okay. Then after showing you that, I could show you as well the pipeline itself, because what I showed you is basically the pipeline, but not the components, not what is inside the image. Okay, and this is the part, what inside the image is the part that can take the most time, because here I have clean text, data downloader, learning classifier, tokenize, and vectorize. So everyone is a component. Okay, let's take clean text, for example. In clean text, I'll have pipeline step. And here, basically, it will detail the, yeah, go ahead.
So I'm sorry, I just unmuted myself. How do we kind of take care of the persistence? Because since it's an image, when one of the component is sharing some, let's say, an artifact between these pipelines, how do they communicate?
They send data this way, the mounted volumes. We use mounted volumes. So basically here what happened is, basically it will save up a portion of the data in /mount, which the next component will take advantage of that information to run its own transformation or so on. And it keeps going like that across the different component that we have. And I named them here. Basically, this is what is left from the first component. This is what is left from the second component. So basically, it save up labels that data that will be used by the third component, and then output clean that data, and so on. So basically, I used mounted volumes in this case. But you could use any other technique, like I feel an S3 bucket can be good, persistent. I mean, different ways can be adapted for this case. But this is just for our purposes, it's fair enough. In other cases where you want to capture this information because you want to use it as metadata and understand what your pipeline does for reporting and BI to show what is going on, well, then maybe you want to save it somewhere else, like in an S3 bucket, for example. You're welcome. All right. So yeah, here we have like the core, or actually what is going on under the hood for every component. So here we have like a transformer method that I imported from my module. And basically here in the pipeline step, we'll basically do the clean text transformer. And then basically will be a part of the pipeline. Same thing for any other component. Like for example, here we can go to the classifier component and have a look at, obviously my way of designing these components or my way of adapting these components, because I didn't design the original ones, is not perfect. You can do better. You always can do better and create more optimized code and more optimized like persistency across your data and your code. Here we have a logistic regression, basically that is being trained. And that's pretty cool because I have something here that is called action. Where is it? It's not, no, it wasn't at here, but it's available here. So technically I could add it as a parameter. So your pipeline can have multiple purposes. So if I decide to add up action here, I could change the purpose of my pipeline. So, and this is again, you being creative and finding use cases for Kubeflow pipelines. And instead of doing training, so using this pipeline to train, you could change completely the purpose of this pipeline and turn it into an inference pipeline that will basically score in batch the new data that is coming in. So basically, instead of being a training, it could become a predict inference pipeline. But that's not the purpose. That's not what we want to do here. So I'll basically delete these. Okay, and we can keep going. We can keep going. Okay, okay. Let's basically now go to the proper. There you go. Now we'll install some required Python libraries. We'll install the requirement.dev5 and then some other packages and dependencies that we need. I usually lose people in this kind of workshop because some of them, they just come to get the document and then they try it home. So they just want the content. It's too bad because I feel like it's always good occasion like this to exchange and talk, and me sharing my expertise and you sharing your expertise. And that's pretty always interesting to have people feedback as well on what we're doing. All right, so now I want to install S2I. Awesome. After that, we'll build the images for every block in our pipeline. So here, basically, if you go under build image, you'll find the S2I command that basically build the image. So I'll be running that shell script every time for every component because I need one image per component. Some images, because they're not used by Seldon, I think it's Data Downloader. Yeah, so it's a Docker build. Why? Just because Data Downloader is basically what will gather the CSV, get the CSV, and then basically send it back to the next component. But the thing is, in my ML engine, in my inference, I don't need a component that will basically download the CSV because there is no CSV here. That's why this one doesn't need S2I to be built, and it relies just on a classic Docker build. So let's run them one by one. Sometimes I have issues with those, so let's see how it goes. Okay. Then you can run all of them. So basically we'll build the image for every, like I said, for every block or component of my pipeline. Working on an image based is pretty good. To be honest with you, when I get in as a consultant in every project, the first thing I look at is on which base they work. Usually it's script based. So I usually convert the workflow to image based because it creates more efficiency. There is not always, because sometimes people, when they run on this with scripts, they have source code to image while Docker can do the same. Can you please explain again why Docker is used for that? Docker is used for data downloader because data downloader is not used by Seldon. So I decided just to go with basic Docker, to show you that technically in other cases, if you didn't use Seldon, you could go with everything on Docker base. Just this, yeah, because we run on Seldon, that's why. But yeah, working on image base quite cool because you don't have that dependency problem when everyone runs on his laptop. Oh, Mohammed, the script that you created to do this and that doesn't work on my laptop. Well, that's normal. You work on with different versions. You work with a different OS, and yeah, it's not compatible. But when you work on images, you know that whatever happened, if your image work and you can run it Docker on your laptop, you know that it will work on mine, it will work in production as well. So it create this consistency for the team. The next step that I didn't do here, because I didn't want to make it longer, but technically after you create the images, you have to push them to a registry. It can be Docker Hub, okay? It can be like Google, Azure, or Microsoft, or AWS, like a registry, image registry. And then basically in your pipeline, you'll be basically using those images as the same thing as I do here. All right, so the last thing to do is, or not the last thing, but an important thing would be to basically run, where is it? Flow train, yeah, it's still here. Now it should be good. Yeah, awesome. So I got like my file compiled. I'll download this package. But before going further, I think we should probably edit the cluster role. This is an important step. Yeah, I'm good. It will be to edit the cluster role. Awesome. And now I'll probably need to add up basically a rule for Seldon. With this, you make sure that Seldon basically would create, because without this, you wouldn't be able to create anything on the namespace when it comes to Seldon. So it will be just like crashing and telling you that you don't have the proper authorization or something similar to this. So I click insert, then enter, then Control V. Awesome. Then escape. Back. I'm good. Another thing is enable the inference for the namespace. If you don't enable the inference, you wouldn't be able to call Seldon or to call your microservices. Awesome. Now we can do a final check on our Kubeflow pipeline. Seems to be good. Not Kubeflow pipeline, but the pods. Sorry. So I downloaded the file, as you can see here. Now I can basically upload, go back to pipelines, and then click upload pipelines. Let's call this Reddit 101. edit case, upload a file, then click create. Awesome. So here you can see our beautiful pipeline waiting to be run. So after that, yeah. I mean, depending on the case. I mean, your pods can be ephemeral, like the one used by the components. It can potentially scale for cell down, for example, depending on the load. And this is pretty cool because if you do load testing, for example, you leave that when we deploy this, yes, well, it's a bit more complex than that, but yes, at the end of the day, your pods host the microservices. They are inside every like your pods, and basically it will basically scale based on the load testing you'll do. So with this, you'll be able to scale up and scale out. Or I forgot, I always confuse both of them, but you understand what I mean. You can scale based on the load that comes in. This is very important for microservices and resource management, because your load, especially in microservices, I've seen it in e-commerce, for example. Sometimes you have crazy peaks. If you don't have like the ability to scale, I mean, it's gonna crash and it's gonna impact the customer experience. So and that's the magic of Kubernetes. I mean, that's why every person that I know, you show him Kubernetes if you never seen it before, and be like, where the hell this comes from? Because it's awesome. It just like manages scaling for you. It has that auto scaling, and another magic is inside the same cluster you can host whatever you want. You can host many different applications. Like here, think about it. Imagine I show this to someone 10 years ago. He'll be crazy. He'll start to cry because he's gonna be, how is it possible to host, like have a virtual cluster where I can host inside a specific namespace different applications and have the ability to scale them? I mean, that's an amazing invention. For me, it's among the top 3 best invention of the last 10 years in the field of, let's say, software development and DevOps in general, which DevOps didn't exist in 10 years, but let's say in the field of IT in general. I'll go that far. Create run. We can choose an experiment. Let's go with default. Use this experiment. And now you have this, run the parameters. That's a feature that I love. So here, for example, it's pointing to a specific data set, CSV file. You could add up whatever you want as a parameter and basically impact your pipeline. Can we build multiple nodes in one cluster? Well, our cluster relies on multiple nodes already. It has multiple nodes in it. I mean, it's very, to be honest with you, Kubernetes, to understand and deep dive in it, as a user, it's okay. It's okay because, you know, you'll figure out how to run things and how to build stuff, how to build a configuration file. But to deeply understand how Kubernetes works and to be able to set up Kubernetes from scratch by yourself, like, that's another level. It requires good skills in DevOps. Yeah, and here I enter my my parameters. It can be parameters related to the model, related to the data source, pointing to specific S3 bucket, specifying specific transformation you want to do. All this can be supported. And then I'll click start. We can look at it. Yeah, it's pretty cool. I enjoy this type of technology. Usually what takes time, and this is like based on the force of Kubeflow, is initializing pods. I'm sure if I click here, it would say initial. Oh, it's already done. It heard me and it says like, okay, I'm gonna do my job. But usually what takes time is initializing the pod. And depending on what you have inside your component, that can take a long time. So you need to take that in consideration while building the pipeline. If there is a requirement for your pipeline for any reason to be fast, make sure that you build optimized images, very important. If you have images, they are like 5 GB of size, don't be surprised at the end that, it's taking forever. Make sure that your setup is proper. I mean, if you run something on GPU and Kubeflow is expecting a GPU, but you didn't set up any GPU available for your cluster, well, don't be surprised that, it's taking forever and never giving anything. I used my mounted volume to be able to temporarily store data. Okay, that basically goes from one component to another. So with this, I have a certain persistency in data across components. But you can use here the artifact store to be able to store them. Basically, can be HTML files, matplotlib visuals, can be a machine learning model that you want to store in the artifact. Or you can create your own model registry or and be able to send the data there. So yes, you have the option to basically, it's flexible. So you decide the architecture at the end of the day. All right. So congrats. It seems to be running. Here you see, here I can see the logs of my pod. So basically here I can have a look at it, which is, to be honest with you, pretty cool for debugging, because you'll be able to know what actually is going on with your component. Sometimes that's the thing. I know that there are logs here, but it takes a bit of time sometimes to load. Never mind. I can have a look at my inputs here. Okay, so the final, not the final step, but the one before is, okay, we have, if we look at here, we're supposed to, we're supposed to look at the cell done deployment. So here we have our cell done deployment here available. We have 5 pods. It's normal because we have cell done orchestrator, because cell done creates its own orchestrator, by the way. And then we have 4 other machine learning, or I'm sorry, 4 other microservices, which are pods. And those 4 are basically 4 different components that have been deployed as an ML engine. We end up with 5 pods at the end. And all of this obviously is scalable, can scale based on the load. So the next step would be to get the IP, because we want to communicate. We want to see if our machine learning model is really providing any result. So let's get the ingress, or let's get the IP. I'll copy that. Then let's use a simple notepad. Look at this. I copied this text basically provided in So I'll enter a test. I'll send a curl. I know. I could make it more complex, something more sophisticated with a script that basically do some load testing. But after a 2-hour workshop, I think that's enough. But yeah, it will be cool maybe later to upgrade this and do something like maybe a bit cooler with load testing and so on. But let's use this simple thing. It's basically a hello world sentence that I'll send with curl to my my deployment. Okay. Awesome. So as you can see here, it's providing results. Here is the original sentence. Hello world, this is a test. Basically, I have the request path. So from the orchestration, it orchestrated, it took the data, send it to the clean text, then to the vectorizer, then to the machine learning model, then to the Spacier tokenizer, which at the end provide us as a return probabilities. So we have 67% of probabilities that this is just this is not like inappropriate content, and 32% that it is inappropriate content. Let's be crazy and see if our machine learning model is really good or not. I'm writing, I am an idiot. Yes, I know. Self-esteem, self-esteem. All right, let's see if I am an idiot is gonna provide any good result. Okay, I am already an idiot. It says that 63% chances that it's inappropriate and 36% that it's appropriate. So our model is doing just fine. So we got our machine learning model deployed or redeployed, because again, this is a retraining pipeline. So it has the ability to deploy if there is no existing prior deployment, but it has as well the ability to redeploy over an existing model. So here we could trigger it on schedule, but as well be able to trigger our performance on trigger our retraining on performance. The last thing that I want to show you is maybe Kati. Very quickly, I'm going to talk about it. Then we can take questions before the end. Yeah, obviously you can take the code. It's inside the documentation. You have the link to the GitHubs. So basically, go on that Git and then fork it, and you can do whatever you want with it. And you have all the necessary references in that document. So basically, Katib is cool for hyperparameter tuning. I'll share the links. I can share the links to the workshop. There you go. And I can share the links to the GitHub. There you go. So Katib, very quickly, hyperparameter tuning or neural architecture search. It's a basic tool. It's a basic tool, but does the job. Except that it can be annoying because it is actually based on configuration files. So you need to generate configuration files, which can be annoying. But in addition to that, you could potentially run basically machine learning models with specific parameters that you want to potentially set up and be able to, for example, run your model or actually find hyperparameters tuning of your model. It's not one of my favorite tools, but it's a good tool and it's open source free. I'll let you explore more if you are interested by yourself. I think they have a full documentation about Katib on Kubeflow website. I already shared with you guys the Kubeflow website. All right, so this is pretty much it. Obviously, there are so many things we could talk about, so many tools. Please, one thing. I don't want you to hate me. When you're done and finished with this, please delete your cluster and delete Cloud9, okay? Cloud is not free. Cloud, it's run by devils because they just like suck your blood and get as much money as they can, but that's their business. And cloud is still magic, but it is what it is. So you're paying for this. So make sure to turn off all this, please, when you're done, obviously. Awesome. I can now maybe take questions if there are some, or maybe you want to discuss about something. I think we still have 15 minutes, so it can be a good time for this. Thank you, much appreciated. I mean, it's always good to share what I know. If you want to encourage me, you can hire me as a consultant, or you can just something more modest, like buy my book. It's available on Amazon. You can as well follow me on LinkedIn. I post every day, always on LinkedIn. I add up my book on Amazon on the chat, and the link to my LinkedIn. I can send you as well a link to my website in case you want to reach out.
Mohammed?
Yes.
Question not on the demo was great. Thank you very much. More on your comment about we need more machine learning engineers. For me, data science is about making a business impact, and I feel like maybe I'm off, but ML engineer is really in the engineering part. And again, for me, it's like a lot of it is systems. So you're pretty far away from the business and making a business impact, even though I realize it's critical to get stuff in production. But I feel like as a data scientist, you're closer to the business problem, the stakeholders, versus here you're really in the weeds of making stuff happen in the cloud. So it's really different.
I think
a different set of tool set.
I completely understand your point. And if we do have this discussion right now, is because the definition of what is a machine learning engineer depends and can vary from a company or a person to another. Sometimes for some companies, machine learning engineers are people just focus on building machine learning models. For others, it's more like what I call MLOps engineer, but it's called machine learning engineer. So yeah, it really depends. For me, and I have a good reading from Andrew Ng with his company. If I can find back that document, I think I have it on LinkedIn. Give me a second, I'm going to send it. I'm going to show it on the screen.
Okay. Because I think my point here is if you're an ML engineer and a data science, to your point, drops a model in your hands, you're just supposed to productionize it, and you don't have a whole lot of insights of sort of or view what is the business problem solving or the interaction with the stakeholders. I feel like you're really way far off with the business and the problems you're trying to solve.
Again, that depends on what's the definition of a machine learning engineer. But for me, and based on some sources I usually follow, a machine learning engineer will be involved at the same time in the development process and can have the ability to develop a model by himself. So he understands the data science, but as well, he has that good understanding of the deployment process, either by using a self-service tool, so something like a click tool, or by coding himself the deployment portion. So basically being able to basically do what we have done right now. So yeah, for me, technically, that's supposed to be the job of a machine learning engineer. That's why I consider them as the bridge at the end of the day. But yeah, again, it depends on the definition of your definition is fine. I'm not saying that I'm right in terms of definition. I'm just you know what, let's forget about the names. Let's make it simple. We need more people that have a good understanding and can build models, and at the same time be able to deploy those models. Because when you have the ability to do both, the process, the workflow becomes so fast, because you already know what you have been created, and you know what is the requirement for production.
Yep, I understand. Cool.
I have a question.
Yeah.
So once the model has been deployed, how do you capture it back and do the and how do you capture it back the results? Like I see that it is so is it true that we just capture the JSON and just parse it and just and put it back into a data set? Is that the easiest way?
What do you mean capturing the JSON?
Oh, so the response. So so going back to the example that you had served, wherein you had like it responded back with a certain output, right? That particular entire pipeline, and you had the entire JSON response. So if you wanted to like capture it back, meaning like create an event out of it and just and push it into your data set, do you just parse the JSON and just push it into the data set and reuse the data? Or
usually you have like logging, and you need to store what is being outcomed here. This
right.
The JSON has to be stored somewhere. Definitely, this is critical, because it's with this data that we will know what is the performance of our model, because we will use this information and compare it to the ground truth, and then see if we are really on target, or if we are drifting, or our model is drifting.
Awesome. Okay, sounds good. Thank you so much.
You're welcome.
So, hi, this is Alex. A quick question. So, how complicated is deploying the same cluster with the ecosystem, like a cloud or any kind of a cloud vendor?
Excuse me, can you repeat that?
Sure. So, how different is the Kubernetes deployment and the whole CI/CD pipeline on a cloud environment?
I'm sorry, I have hard time hearing you. There is background noise.
Oh, sorry. So is it better now? So only the question was like,
now it's way better. Go ahead.
Sure. So the question was like, how complicated is this whole setup, creating an end-to-end pipeline on a cloud environment, and how would the stack differ?
Creating an end-to-end pipeline on the cloud. Do you talk about the CI/CD? Which portion do you talk about?
So the CI/CD, including creating the SI image, the S2I, as well as a Docker image, and then deploying that specific model onto the cloud for serving.
Well, creating the environment, then being able to create, every component, and the most important thing, change people, they work actually in the company when it comes to machine learning. This is like a 6 month to a year work. Usually we slice it in smaller portions. We start, for example, by going where there is gap and urgency, can be tracking experimentation, can be pipelines, automated pipelines, can be deployment. Usually people, they always start with deployment portion and investing in a deployment solution with a framework and an approach. But yeah, it can take, depending, in some companies it can take a couple of weeks because it's a simple workflow they have in machine learning lifecycle. Others, it can take like years because they are a very large organization, and it's usually a roadmap over multiple over an environment that you implement, and that basically scale with the time, and you have components that might change or be added up. I've seen that in banks, for example, where I work. The environment is not static. You implement the first MVP, then you make it evolve, then you need to take care of additional cases in machine learning that relies on streaming, for example, or anything else. So, and all this can take time. But it's definitely not an easy process, but it depends on the complexity of the company cases in machine learning and machine learning lifecycle complexity, actually.
Sure. Yeah, that answers my question. Thank you.
You're welcome. Okay, I think I got the document. Give me a second. So this is the document I was talking about by Workera, which is a company of Andrew Ng that all of you probably know. And here in this, basically, he classifies the data scientist first as someone that does a bit of data engineering, modeling, and then he does the business analysis, but he doesn't do the deployment. While he sees the machine learning engineer in this document as involved in data engineering, modeling, and deployment. So it's maybe someone that has less focus on business analysis and would be more covering data engineering, modeling, and deployment. The document is super interesting because it covers like other profiles. Here, what they call software engineer ML is actually a data engineer, close to a data engineer. So yeah, I mean, the document is pretty cool because in that document you have all the rules that are detailed with the task, what it takes, business analysis, AI infrastructure, and the role inside with what skills does it require. I'll send you the link if you are interested to this document. Have a look at it. Pretty much interesting. At least I try to follow someone that or something that is a bit serious. And again, I'm not saying that this is right. At least it has credibility because it comes from like N2NG startup basically. So it's supposed to be a reference document. But again, there is no proper answer. At the end, we understand each other that we need a bridge. We need people that are capable of being involved in development of machine learning, but as well in production. Any other comment, question you might have? We still have 2 minutes left. Maybe Eric, you seems very quiet. It's very unusual from you.
Yes. Sorry, I had to go off the call for the past 10 minutes.
No problem, no problem, no problem. I hope you enjoyed the
yeah,
workshop.
It was a really thorough explanation of Kubeflow. That will be a good way to start the changes from most of the tutorials where they focus on the data science part rather than the operationalization part.
Awesome. Awesome. So please guys, add me on LinkedIn. I'd be more than happy to chat with you, exchange, and you could follow me as well. I post interesting things about tools and so on. Awesome. I think I'm done for today, Faraz. I'll leave you the spot to end up this.
Awesome. Thank you so much for once again for such a fascinating and detailed workshop. And thanks everyone for joining, and thanks everyone for sticking around. As Mohamed mentioned, the workshop is recorded, so we'll share the recording and the slides and kind of the resources as well too. So thanks everyone. Thanks, Mohamed.
Thank you.
See everyone.